So before we start this session, let's look back at our last lesson, last question. The adventure film starts at 15:15 and ends at 17:00. The space film starts at 15:25 and ends at 17:05. Explain how you know which film is longer. Now, in order to answer this question, you're going to have to be using the paper-based methods we used in our last session to allow you to show which one is going to be longer. By using those ideas, you don't need to write out a paragraph to explain. You can simply show you're working out, and to anyone who looks at that, it should be clear whether it's the adventure film or the space film which is going to be longer, and your reasoning behind it should be really quite clear. So the adventure film starts at 15:15 and ends at 1700 hours. The space film starts at 15:25 and ends at 17:05. Explain how you know which film is longer. So pause the video, go and work this out, and then come and join me when you're ready to look at the strategies we've been using. So let's look at how we solve this. We know we have an adventure film that lasts for a certain length of time, a space film that lasts for a certain length of time, and we need to know which one lasts longer. So what we need to do is find the duration of both films in order to answer that second part, which one's going to be longest. So let's start with our adventure film, which starts at 15:15. Now we know the film starts at 15:15, so I'm going to make my jump to the next hour. And that next hour is 1600 hours. And what I've done there is I've made a jump, nice and simply, of 45 minutes. Now my next jump is going to go from 1600 hours, 1600, to 1700 hours, 1700. And as with anything, what I'm going to do, I'm going to keep my units the same. So although I know that's 1 hour, I'm going to say that that is actually going to be 60 minutes. Because that's going to make the next stage far simpler. Now, one of the big mistakes we can make here is forgetting that there are 60 minutes in an hour, and we can end up going 15:15, we're adding on 45 minutes, 1600 hours to 1700 hours, we'll add on an extra 100 minutes. And of course that's going to be wrong, so we need to be really tight on the idea, 60 minutes in an hour. We're working on a different base system for this. So we can see here, 15:15 to get to 1600 hours, 45 minutes, 1600 hours to 1700 hours, 60 minutes, 60 minutes plus 45 minutes, gives me an answer of 105 minutes. So the adventure film is going to have a duration of 105 minutes. Now the next stage is for me to look at the space film. And again, we can see that this starts at 15:25. So I'm going to make my first jump, which is going to go to the next full hour, which is 1600 hours. So I'm going to make that jump from 15:25 to 1600. I'm going to remember that there's only 60 minutes in an hour. So when I'm looking at this, I'm going to count from 25 over to 60. Or I'm going to use my analog clocks or whatever other methods. And in this case, I know that is going to be 35 minutes. Now my next step is going to be to go from 1600. I'm going to go to my next hour because I know that the space film is going to start at least another hour later at 1700 hours. And again, when I'm doing this jump, I'm not going to be talking about hours, I'm going to be talking about minutes. So in this case, it's 1 hour or 60 minutes. And again, like I said, this is the thing that stops me from slipping into 100 minutes into an hour, because I'm consciously thinking about this. And then we know the film doesn't stop at 1700 hours, it stops at 1705, which means I have another jump here of 5 minutes. And we can see that the duration from 15:25 to 17:05 is 35 minutes, 60 minutes, and 5 minutes, which gives you a total duration of 100 minutes. So the space film that starts at 15:25 and ends at 17:05 lasts for 100 minutes. And now I can think about that final part of our question. Explain how you know which film is longer. Well, we've now calculated that the adventure film duration is 105 minutes, and the space film duration is 100 minutes. So we now know the adventure film is longer than the space film. And from doing that working out, that's how I've explained how I know. And the answer shows that really clearly. So by showing your working out, by showing your methodology, you're able to actually show someone without having to write words and sentences and paragraphs where you could potentially write lots and lots and never actually explain why. So in this case, the adventure film lasts for this length, the space film lasts for that length, and you can tell by that the adventure film is longer. And now we're going to move on to today's session, and this is where we're going to start learning to find the start and end times to the minute for different events. So it's almost like a missing number problem, where we'll be looking at the idea for duration, but we'll only be told a start time or we'll only be told an end time. We'll have to use that piece of information along with the duration to be able to find out when the start or the end time of an event is going to be. So let's turn to our textbooks, and we can see that our questions relate to our fairground, and we can see the first one, which is 1A. Max has just started queuing for the dodgems. When will he get on? Now, thinking about this question, be looking at the image and see what we can find out. What time is it at the moment? How do we know this? Could it be said into a different way or anything like that? Then I want you to think, what information do we have about the dodgems? Does that help us to work out when Max will get onto them? And for question 1B, when should Olivia start queuing for her ride? She says, I want to go on the big wheel at 4:05. When should Olivia start queuing for her ride? Again, think about what time it is that she wants to go onto this ride. Think about the information we know about the big wheel and see whether that can help you to identify that start time. So question 1A, Max has just started queuing for the dodgems. When will he get on? Question 1B, when should Olivia start queuing for her ride? Pause the video, try and solve those two calculations for me, and then come and join me when you're ready so we can have a look at the strategy you're using. So let's begin with our first question. Max has just started queuing for the dodgems. When will he get on? Well, we know that there's a time on the tickets office, and we know that the dodgems, you're going to be queuing for 6 minutes. So what we're going to be thinking about on this one is this. We have our start time, the clock, which is shown on the ticket office. We have our duration, the amount of time that he's going to be queuing, and our end time is going to be that time where he's finished queuing and he's now going to be on the dodgem. If we look at that idea using pictorial representations, you can see we have our start time, which is shown on that clock. We then see on the sign that there's a 6-minute queuing time for the dodgems. So we have the time where we currently are, the start time. The duration he's going to be queuing is going to be 6 minutes, and that's going to lead us to the answer, which is going to be our end time, that time when he's going to be sat on the dodgems. So if we look at our clock, we can firstly find out that the start time is between 2 o'clock and 3 o'clock. If we work out the minutes past, we can see that we're past 9, so 5 lots of 9 gives me 45. So I'm later than 2:45, and if I look very carefully, I can then go 46, 47. So my time at the moment is 2:47. When I'm looking at the dodgems, I'm going to be looking at queuing for 6 minutes. So I've got that time of 2:47, and I'm now going to count on 6 minutes. And we can see on our next clock, I've shaded in blue those 6 minutes. So we've got 2:47 when he starts queuing, 2:48, 2:49, 2:50, we're 3 minutes into our queuing time, 2:51, 2:52, 2:53. So at 2:53, he's done his 6 minutes of queuing up. So in this case, we've looked at the idea of the time, adding on the 6 minutes to get our end time. And if we ignore the hours just for a moment, we can make this into a nice simple number sentence. There's 47 minutes past. We're going to add on 6 more minutes, which means it's going to be 53 minutes past. And we can add on the hours later. So Max will get on the dodgems at 2:53. When we look at problem 1B, we can see our question is, when should Olivia start queuing for her ride? Well, she tells us that she wants to queue to get onto the big wheel, and she wants to be on the big wheel at 4:05. So we know that she wants to be there at 4:05. There's going to be a 30-minute wait in order for her to do that. So to do this one, I'm going to use subtraction to help me. And the reason for that is because I'm actually starting with my end time. I know that Olivia is telling me she wants to be on the big wheel at 4:05. So that's the time where I'm going to start with. And what I'm now going to do is I'm going to start taking things away. And if we look, firstly, we can see that the big wheel has a queuing time of 30 minutes. So we know that Olivia wants to be on at 4:05, but we know that she's going to have to start queuing 30 minutes earlier. So we're going to have to subtract 30 minutes from 4:05. However, I'm going to now do this in 2 stages. I'm going to do my first jump, which is going back from 4:05 to 4 o'clock to jump back 5 minutes. And now I'm going to do my second jump back, which is going to be the remaining time of my 30 minutes, which is going to be another 25 minutes. And now we can see that remaining 25 minutes that I've subtracted shaded in blue. So I've started at 4:05, I've taken away 5 minutes, and then I've taken another 25 minutes after that. And that gives the duration of time that Olivia will have to be queuing in order to get onto the big wheel at 4:05. Which will mean Olivia needs to start queuing at 3:35. So on this one, our end time is the time she wants to be on the ride. We've subtracted the amount of time that she would actually be queuing for the big wheel, the duration of that queuing time, in order to give us that start time. So be noticing the difference between these two methods that we've been looking at. For question 1A, Max has just started queuing for the Dodgems. When will he get on? Well, we know he's there now, and we're asking when it will be that he's going to be sat on that ride. So we're counting on. So we know he's doing something now, but we know he's going to have to wait in order to do it. For Olivia, when should she start queuing for a ride? Well, we know what time she wants to be on that ride. So we know when she wants to finish. So what we're going to have to do now is do our counting back in order to find out when she needs to start that journey herself. So we can see Max, we've been counting on. Olivia, we've been counting back. So we've been finding for Max the finish time and for Olivia the start time. Now take your time on these, because the first thing is to understand what the problem is asking you to find a start time, where you're going to be counting back, or is it going to ask you to find an end time, where you're going to be counting forward. And be remembering that base that we were talking about, 60 minutes in an hour rather than 100. So now it's time to continue with the textbook questions, and once you've finished those, moving on to the workbook. Good luck, and I look forward to see how you're applying all those different things that we've looked at in this unit in today's session. So good luck, and I look forward to seeing your work.